Welcome to this video that introduces you to vector embeddings in relational databases. After watching this video, you will be able to describe what vectors are in the context of AI, explain how relational database management systems access vector data, identify some of the current large language models used to create vector embeddings, describe how to create embeddings using Zenova transformations, explain how to create vector embeddings using TensorFlow in Node.js, and measure similarity between vectors using cosine similarity and other distance metrics. Mathematically, vectors are collections of scalar values arranged in a specific order. Vectors are limited to 3 dimensions in math because of the 3 dimensions that humans can see and perceive. In contrast, in the context of artificial intelligence, vectors are multidimensional data objects that represent text, images, videos, sensor readings, and other entities. The number of dimensions associated with the data embedding varies depending on the data and the data model that you are using to encode the data into an embedding. While the embeddings can be stored as numeric arrays, searching the arrays stored in SQL databases can be memory-intensive and time-consuming. Every time a search operation needs to be done, all the vectors are retrieved, the cosine similarity is calculated, and the matching string is returned based on the value of cosine similarity or distance. The vector length for image, video, and audio data tends to be much bigger than the text data. To provide for this situation, most RDBMS systems now provide a wrapper or add-on on top of the existing RDBMS that allows having a vector as a data type and allows retrieving the data intrinsically based on the similarity between vectors rather than manually calculating the distance or cosine similarity. Pre-trained machine learning models, trained on millions of data items, create these embeddings. Some of the most commonly used model resources that aid in creating vector embeddings for text-based data include Hugging Face that creates text embeddings using Word, 2vec, Glove, and Paragram. TensorFlow Universal Sentence Encoder that creates embeddings using deep learning models optimized for greater than word-length text. OpenAI that creates text embeddings using transformers, like GPT models, and Google Generative AI that creates text embeddings using machine learning techniques, such as BERT and other transformer architectures. Next, learn about using Zenova Transformer with Hugging Face to create embeddings. Hugging Face is a hub of more than 100,000 pre-trained models for different kinds of data. To use the Hugging Face hub in Node.js, we use the Zenova Transformers library. Zenova/Transformers is a Node library that supports access to the large language models within the Hugging Face hub. You can quickly install at Zenova/Transformers and generate vector embeddings for text. Zenova loads pre-trained models for text feature extraction using vectorization, translation, sentiment analysis, image recognition, and other tools. Let's look at how you do that. First, you import at Zenova/Transformers asynchronously. Next, initialize the pipeline with the task you want to do, which in the case of this example is feature extraction, and then specify the model's name for feature extraction. You can choose from many models of feature extraction. This example uses Zenova/all mini LML6 v2. You then pipe the word you want to encode into a vector and print the output. Then store the vector in the vector database when the database becomes available. As expected, the vector embedding consists of an array of floats. The length of the array varies depending on the input. Here's a sample array of the word hello embedding generated using Zenova feature extraction. You can see that the embedding vectors are long numeric arrays that you can store in relational databases. The length of this embedding is high, as the embedding depends on the model you used, and embeddings require computer interpretation, as the embedding does not exist in a human inferable form. Next, experience how to create an embedding for a Node.js application. The code first includes TensorFlow for the JavaScript package and loads the TensorFlow Universal Sentence Encoder. The TensorFlow Universal Sentence Encoder is a pre-trained model in your JavaScript file. You then load the model and embed the sentence in the model. This action returns the vector embedding as a float array. Next, examine this sample array of the word hello generated using TensorFlow embedding. This embedding has a float array of length 512 and is not in a human inferable form. This embedding exists based on the model's training, which considers many aspects of the word, such as the letters, the words before, the words after, and the word's overall context. After creating the embedding and adding your vector embeddings to a database, you can search for vectors based on the distance, such as Euclidean distance between the vectors, or using measures such as cosine similarity. Cosine similarity helps you measure the similarity between the query string and the vectors in the database, and ideally helps retrieve the records with the highest similarity score. The value ranges from 0 to 1, with 0 being the most dissimilar and 1 being the most similar. Cosine similarity between vectors A and B is the measure of the cosine value of the angle between the two vectors to see if they are pointing in the same direction. You calculate cosine similarity using the following formula: cosine similarity of AB. B equals the dot product of A and B divided by the product of the magnitudes of A and B. When the cosine similarity between the two vectors is close to 1, then objects represented by the two vectors are similar. OpenAPI and Google Generative AI provide vectorization services based on trained models using API keys, which you need to obtain from their websites. After you obtain an API key, you can connect to the model using the API key and credentials, and then generate embeddings, similar to TensorFlow and Hugging Face. Then, you can use their libraries and packages to vectorize your data. In this video, you learned that in the context of artificial intelligence, vectors are multidimensional data objects that represent text, images, videos, sensor readings, and other entities. Most RDBMS systems now provide a wrapper or add-on on top of the existing RDBMS that allows vector data types and retrieving the data intrinsically based on similarities. Commonly used models that create vector embeddings for text-based data include Hugging Face, TensorFlow, OpenAI, and Google Generate AI. To use Zanova transformers, import the transformers, initialize the pipeline with your task, and specify your model's name. To use TensorFlow, load TensorFlow.js, and the universal sentence encoder, and embed the input sentence using the model. When the cosine similarity between the two vectors is close to 1, then objects represented by the two vectors are similar.